Hello everyone, my name is B. Sathik. I am from CSED section. Today my topic for theory of computation concept video is applications of finite automata. Finite automata. Finite automata is the simplest machine to recognize patterns. The finite automata or finite state machine is an abstract machine that has 5 elements or tuples. It has a set of states and rules for moving from one state to another, but it depends upon the applied input symbol. Basically, it is an abstract model of a digital computer. The following figure shows some essential features of general automation. The L1, L2 and the Ln line represents the input. The Q1, Q2 and Q1 line states the states of automata. O1, O2 and O3 states the output of the automata. Finite automata are used to recognize patterns. It takes the string of symbol as input and changes its state accordingly. When the desired symbol is found, then the transition occurs. At the time of transition, the automata can either move to the next state or stay in the same state. Finite automata have two states, accept state or reject state. When the input string is processed successfully and the automata reached its final states, then it will accept. The strings and languages can be accepted by a finite automata when it reaches to the final state. There are two preferred notations for describing automata. They are transition diagram and transition table. Transition diagram. A transition diagram or transition graph can be defined as collection of finite set of state k, finite set of symbols, summation, a non-empty set of s of k. It is called start state, a set f that belongs to k of final states. A transition function kx that tends to k with k as state and a as input from summation star. A transition diagram or state transition diagram is a directed graph which can be constructed as follows. There is a node for each state in Q which is represented by the circle. There is a directed edge from node Q to node P labeled if delta Q comma A is equal to P. In the start state, there is an arrow with no source. Accepting states or final states are indicated by double circle. Some notations that are used in transition diagram. Q1 state, arrow transition from one state to another. Start arrow Q0 or Q0 bar start state. Q1 or double Q1, double circle Q1 final state. Transition table. The transition table is basically a tabular representation of transition function. It takes two arguments, a state and a symbol, and returns a state, the next state. A transition table is represented by the following things. Columns correspond to input symbols, rows correspond to states, entries correspond to next state. The start state is denoted by an arrow with no source. The accept state is denoted by a star. There are two types of finite automata. DFA, deterministic finite automata. NFA, non-deterministic finite automata. Finite automata is divided into two, DFA and NFA. DFA, deterministic finite automata. DFA refers to deterministic finite automata. Deterministic refers to uniqueness of the computation. In the DFA, the machine goes to one state only for a particular input character. DFA does not accept the null move. DFA consists of 5 tuples: Q, summation, small q, f and delta. Q, set of all states. Summation, set of input symbols. Symbols which machine takes as input. Q, initial states. Starting state of a machine. F, set of final state. Delta, transition function defined as delta tends to q into summation tends to q. DFA, deterministic finite automata. There is a description of how a DFA operates. In DFA, the input to the automata can be any string. Now put a pointer to the start state Q and read the input string W from the left to right and move the pointer according to the transition function. Delta. We can read one symbol at a time. If the next symbol of the string W is A and the pointer is on the state P, move the pointer to delta P comma A. When the end of the input string W is encountered, then the pointer is on some state F. The string W is said to be accepted by the DFA. If R belongs to F, that means the input string W is processed successfully and the automata reached its final state. The string is said to be rejected by DFA if R does not belong to F. Example of a DFA. NFA. NFA stands for non-deterministic finite automata. It is used to transmit any number of states for a particular input. It can accept the null move. It is easy to construct an NFA than DFA for a given regular language. The finite automata are called NFA where there exist many paths for specific input from the current state to the next state. Every NFA is not a DFA, but each NFA can be translated into a DFA. NFA is defined in the same way as DFA, but the following two exceptions: it contains multiple next states. NFA also have 5 states same as DFA but different transition functions as shown. Q finite set of states, summation finite set of input symbol, Q naught initial state, F final state, delta transition function. Delta tends to Q into summation of 2 power Q. This is the example of NFA. Types of automata. Some important points about DFA and NFA. Every DFA is an NFA, but NFA is not a DFA. There can be multiple final states in both NFA and DFA. DFA is used in lexical analysis in compiler. NFA is used in theoretical concepts. Application of finite automata. We have several applications based on finite automata and finite state machines. Some are given below. A finite automata is highly useful to design lexical analyzers. A finite automata is useful to design text editors. A finite automata is highly useful to design spell checkers. A finite automata is useful to design sequential circuit design. So this is all about finite automata and its applications. Thank you.